Today we're going to review slope-intercept form for equations of a line, and this is Chapter 2, Section 3. And slope-intercept form is y equals mx plus b, which is the one that you're probably most familiar with. So we'll start right in with an example. The first example has an equation written in standard form, and we're going to rewrite it in slope-intercept form. And then once it's rewritten in that form, it makes it easy to identify the slope and y-intercept. Okay, so we'll start with this 3x plus 4y equals 4. And our goal is to solve it for y. So we're going to move everything away from the y. So we're going to go ahead and subtract that 3x. And so now I have 4y is equal to negative 3x plus 4. And then we want to further isolate, get y by itself. So it's 4 times y. We'll do the inverse. We'll divide by 4. And so now I have the equation y equals negative 3 divided by 4x plus 4 divided by 4, or 1. Okay, so we have negative 3/4 x plus 1. This is your m value, or your slope, which is equal to negative 3/4. And this is our y-intercept, or b value, or in this case, a positive 1. Okay, and the y-intercept is 1, or the point 0, 1. So on the y-axis, your value of x is 0, and therefore you'd have the point 0, 1. Okay, I'd like you to pause the video and try example 2. Welcome back. We're going to go ahead and graph that problem from example 1. And so you'll notice it's the same exact equation, which is y equals negative 3/4 x plus 1. And so we can use the slope and the y-intercept to graph it. So if we know that our slope is negative 3/4, okay, then we know that is the same as 3 over negative 4. Okay, and so we can use those in terms of plotting or graphing. And also these are both the same as negative 3/4. So you can think about it either way. Okay, and then we have our y-intercept, which is that positive 1. Okay, and so we'll go ahead and we'll start with the y-intercept. We'll start at positive 1. And then from that positive 1, we'll use our slope. We know it's going to be negative 3 over positive 4. So that means down 3 over in the positive direction 4. Down 3 in the positive direction 4. Or we could start from that y-intercept and go up 3 and back, or in the negative direction 4. And then up 3, back 4. And then once we have those points, we can go ahead and make our graph. Okay, we'll make sure that we go ahead and include arrows and label y equals negative 3/4 x plus 1. Okay, I'd like you to go ahead and graph the second equation, which is not the same as the second equation from above, so you'll have to do a little bit of work in order to graph that. Okay, and then we'll take a moment to do 2 last examples. The first is dealing with parallel and perpendicular lines. Solve each equation for y, compare the slopes, determine if they're parallel, perpendicular, or neither. To review, parallel lines have the same or equal slopes. Perpendicular lines have negative reciprocal slopes. So parallel, perpendicular, and then neither means that they don't have equal slopes and they don't have negative reciprocal slopes. So we'll take a look at the first example, and the first example is already in y equals form. So in this case, we're just going to consider the slopes, and so we have slope of negative 2 for both of them, so that we can say L1 is parallel to L2. Okay, or you can just write the word parallel. whatever feels comfortable for you. Okay, and then we'll go ahead and try a second example where they're not already in y equals mx plus b form. So we'll take L1 and we'll work with that first. We have 2y equals negative 3x plus 2. And we'll go ahead and solve that for y. So we'll divide by 2. And then we'll go ahead and we'll deal with L2. Okay, we're going to isolate that y, so we'll add 4x to both sides. So now I have 6y is equal to 4x minus 12, and then we'll go ahead and divide by 6. So I have y equals 4 over 6x, so 4 over 6 can reduce to 2/3. And negative 12 divided by 6 gives me a 2. Okay, and then once I've solved for y, I'm going to go ahead and consider the slopes of each and compare them. So in this case, I have a negative 3/2 and a positive 2/3, which means that they are negative reciprocals. And so since they are negative reciprocals, these are perpendicular. And again, you can use the symbol. You can say L1 is perpendicular to L2, or you can write the word perpendicular. Okay, again, I'd like you to either pause the video now or after the video, go ahead and complete number 3 and number 4. Okay, the last type of problem we're going to do is using the slope-intercept form, the y equals mx plus b form, to find the equation of a line. So we have a line with a given slope of negative 3, and it passes through that point. Okay, so we have y equals negative 3x plus b. We need to go ahead and find that b value, the y-intercept. So how do we do that? Well, we know this point, xy, and so we can go ahead and sub in those values for x and y in this equation. So we would sub in, wherever we see a y, we're going to put in a negative 4 equals negative 3 times x plus b. Okay, so I have a negative 4 is equal to negative 3 times 1 plus b. And then I'll go ahead and I will try and isolate b. That means I'm going to add 3 to both sides. And so on this side I have negative 4 plus 3, or negative 1, is equal to b. So now I have my m and I have my b, and so I'll rewrite my equation. Y equals negative 3x minus 1. So we can plug in that y-intercept. Okay, again, I'm going to ask you to try and complete number 2 on your own. I'll see y'all tomorrow.